Hello my learners, I am back with some important questions on the topic tangents. Last video we studied what a tangent is, I explained you what is a secant, and then we saw all the theorems related to tangents. This video is about 10 very important questions about tangents. These are very important for your CBSE boards 2023. So do not move till the entire video is completed. Let's get started. So the first question says, okay, before starting with the question, I'm going to give you some important tips. The first tip is, stay with me till the end of this video. I mean to say, fasten your seat belts. Next is, when we start doing the question, just read the question. We'll read the question. I'll explain you what the question says and then pause it. Just pause the video. Try to solve the question by yourself. And just comment down who all are able to do it. Tip number 3. If some of my champions there are not able to solve it, just see some part of the solution. See how I start with it. Pause when you see some of the solution, till half of the solution you see just. And after that, try to pause it again and try to solve the question by yourself. And we have to do this for all the 10 questions. So let's get started. What is the first question? The first question says, in the given figure, xy and x dash y dash are two parallel tangents to a circle with center O, and another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. We have to prove that this angle AOB is equal to 90 degree. So the question says that xy and x dash y dash are two tangents to the circle. They are two parallel tangents to the circle. We have another tangent AB whose point of contact is C and it is intersecting xy at A and x dash y dash at B. We have to prove angle AOB. That means this angle we have to prove as 90 degree. Come on, pause the video and try to solve it yourself. What we'll do, we have to do some construction. We are going to join OP, OQ, we'll join OP, OQ and OC. Next, we know angle OPY. Just tell me, what is angle OPY? Yes, it is 90 degree from theorem 1. The line joining the center and point of contact is perpendicular to the tangent. So this will be 90 degree. Similarly, these angles are also going to be 90 degree. Next what we'll do, OPA and OCA, just try to prove, we'll make these two triangles congruent. Triangle OPA and triangle OCA. So in triangle, which two triangle we are taking? We are taking OPA and triangle OCA. Just take these two triangles and make them congruent. So first we have OA is equal to OA, which is common. Next is OP is equal to OC. They are the radius of the same circle. So it is radius. Next is angle OPA is equal to angle OCA, which is 90 degree. Just write the theorem. I am writing theorem 1. You have to just write the statement of that theorem. Okay. So these two triangles are proved congruent. Just tell me the criteria. Yes, you are right. The criteria is RHS. It's RHS. These two triangles are congruent. So now we can say, after proving them congruent, we can say angle POA is equal to angle AOC. What we can write? POA is equal to angle AOC by CPCT. Corresponding parts of congruent triangles are congruent. So if these two are equal, let us assume these two angles as x. Let us assume these to be angle x. Again, similarly, we can prove these two triangles also as congruent. Triangle OCB and triangle OQB. Similarly, you prove triangle OBC and OBQ. Again, OC is equal to OQ, radius of the circle. OB is equal to OB common, and OQB is equal to OCB 90 degree. By RHS criteria, these two triangles are congruent. So we'll write these two congruent by RHS. After proving them congruent, we can say that this angle is equal to this angle. That means angle BOC is equal to QOB. Angle QOB is equal to angle BOC. Again, CPCTC. These two triangles are congruent. Assume these two triangles as angle as y. They are y degree. Next, these two are parallel lines. We know OP is perpendicular to XY and OQ is perpendicular to X dash, Y dash. So if these are co-interior angles, if the co-interior angles are perpendicular and these two tangents are parallel, we can say it is a straight line. This is a transversal to these two parallel tangents. So we can write X plus X plus Y is equal to 180 degrees since it is a straight line. So we get 2x plus 2y is equal to 180 degree. 2 we'll take common, and here we get x plus y is equal to 90 degree. X plus y we have proved as 90 degree, and x plus y is this angle, which is angle AOB. So we have proved AOB is equal to 90 degree. The next question is, if the angle between two tangents drawn from an external point P to a circle of radius A, the radius A is missing. It will be to a circle of radius A and center O is 60 degree, we have to find the length of OP. So in this question, we have been given an external point P. We have drawn two tangents to this circle whose center is O. So two tangents are PA and PB. We have to, and the length of the radius is given as A. We have to find the length of OP. We have to find what is the length of OP. Again, pause the video and just try to solve it. Okay? Now, if what is given in the question, given is OA is A. This is given. Next, also we have been given angle APB is 90 degree because it's given the angle between the two tangents. The two tangents are making angle as APB. So we'll write angle APB is 60 degree. Now, in the last video, what we studied, when two tangents are drawn from an external point, then the length of the tangents are equal first. Second is they subtend equal angle at the center, and the third was they are equally inclined to the line joining the center to that point of contact. That means they are equally inclined to this line. The two tangents are equally inclined to OP. That means angle APO is equal to angle OPB from theorem 3. So you have to write the entire statement. Angle, we can write angle OPA is equal to angle OPB, which will be equal to 60 by 2 because the entire angle APB is 60 degree. It will be 60 by 2, which is 30 degree each. So these two are 30 degrees. Next we can write angle OAP. Just tell me what will be angle OAP? Yes, it will be 90 degree again from theorem 1, and this is theorem 3. If this is 90 degree, so The triangle OAP is a right angle triangle. We have angle OAP as right angle triangle, and we know angle P is 30 degree, and we know the length of OA, which is the radius of the circle, is A. Now we have to find OP. So using trigonometry, can't we find the length of OP in terms of A? Yes, so what we'll use this, the opposite of this is OP, and we have to find the opposite of this angle is OA, which is a radius, and we have to find OP, which is a hypotenuse. That means we have perpendicular and hypotenuse. So which trigonometric ratio are we going to take? Yes, we'll take sine. So we'll write sine 30 degree is equal to perpendicular by hypotenuse, which is OA by OP. What's the value of sine 30? Just put the value of sine 30. This is half. Half is OA by OP. So we'll get the value of OP. What will be OP here? OP is 2 times OA. So it was so simple, right? Now let's move on to the next question. Let us see what is the next question. So the next question is, prove that the tangents drawn at the endpoints of a chord of a circle make equal angles with the chord. Before starting with this question, let me tell you one more important thing. That is, these questions are very important. They are very important. If you want to score good marks, you should practice all these questions. Also, you practice the 3 theorems, which I taught you in the last video. Those theorems are also very important. They also can be asked. You can be asked to prove that the length of tangent from an exterior point are equal, or you can be asked to prove any of the theorems. So mark my points. Those 3 theorems were also very important. Get back to the question. We'll get back to this question. What's the question? Prove that the tangents drawn at the end point of a chord of a circle make equal angles with the chord. These are the endpoints of the chord. PQ. PQ is the chord. The endpoints are P and Q. So we have to prove they are making equal angles with the chord. That means we have to prove this angle is equal to this angle. Okay. So what we'll do, this is the center O. Okay. This is center O. The construction which I am going to do is, I'll join OP and OQ. First step is, you can write like that. The construction, just write the construction in each and every question. Just write what construction you have done it. So construction is join, what have I joined? OP and OQ. Now, again from theorem 1, angle OPB will be equal to 90 degree. Also angle OQC will be equal to 90 degree, right? So we can write angle OPB is equal to angle OQC. Theorem 1. I am repeating it again. Do not write theorem 1, write the statement. Next, now see in triangle OPQ. In triangle OPQ, what do we have? We have OP and OQ as the radius, which are equal. So it is an isosceles triangle. So in this triangle, we have got OP is equal to OQ. We will write radius of the circle. So if these two sides are equal, will not angle P and angle Q be equal? Yes, angle P will be equal to angle Q. What is the reason? Angles opposite to equal sides are equal, which everybody knows. Angles opposite to equal sides are equal. Now again, we'll take these angles as x. Suppose if I take these angles as x. Let angle OPQ is equal to angle OQP is equal to x. I'll just write that down. If this is x, what will be angle QPB? Just tell me. Yes, it will be 90 minus x, because this full is 90 degree. We know this is 90 degree. So this will be 90 minus x, and similarly angle PQC also will be equal to 90 degree, which we have proved, which was what the question said us to prove, that we had to prove that tangents drawn at the end points of the chord. These two were the tangents which were drawn at the end point of the chord PQ. We had to prove that they were making equal angles with the chord. That means we had to prove this angle is equal to this angle, which we have done it. Now, let us move on to the next question. Question 4. What does this question say? A circle touches all the four sides of a quadrilateral ABCD. We have a quadrilateral ABCD. We have a circle inside it, inside the quadrilateral. We have to prove AB plus CD is equal to BC plus DA. Come on, let us try. Again, I'll advise you, which I am repeating it again. Just pause the video to try to solve it yourself. And just write down in the comment box who all were able to do it. Let us start with this question. What do we know? Yes, from theorem 3 we know the tangents drawn from the external point of a circle are equal. Tangents drawn from an external point to a circle are equal. So we can write, if we see from point A, we have two tangents which is AP and AS. So can't we write AP is equal to AS? Again, write the statement of the theorem. Tangents drawn from an exterior point to a circle are equal. Similarly, we'll write BP is equal to BQ. Again, theorem 3. Next, we can write CQ is equal to CR, or CR is equal to CQ. Anything we can write. Next, we'll write DS is equal to DR, or DR is equal to DS. See, what we have to prove, just see it very carefully. We have to prove AB plus BC is equal to AB plus CD is equal to BC plus AD. What we'll do, we've got 4 equations. Okay, add all these 4 equations. We just see what we'll get if we add all the 4 equations. Now see, we have to add, what we'll do if we add all the 4 equations, just AP plus BP plus CR plus DR. Let us see what is AP plus BP. Yes, we are getting AB. Next is in this left hand side, I'm talking about left hand side first. CR plus DR, just see it, see on the board. CR plus DR, which is CD. So we are getting on the left hand side AB plus CD. That is why over here I wrote CR is equal to CQ. CR I wrote on the left hand side is equal to CQ, and then CR was on the left hand side, so I wrote DR here because CR plus DR will give me CD. So we have to make arrangements like that. So we'll add, if we are going to add the left hand side, what are we going to get? This is equation 1, this is 2, this is 3, and this is 4. When we add the equations, how we add? Left hand side, we add all the left hand side, and then we add all the right hand side. As we know, if A is equal to B and C is equal to D, we know that A plus C will be equal to B plus D. Everybody knows that. Okay, so we can write, we'll write adding all the 4 equations, we'll write AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. So we'll arrange it like that, AS plus DS, of course, AS plus DS. So we'll write AS plus DS plus BQ plus CQ. So what is AP plus BP? Yes, it is AB. What is this? CR plus DR. It is CD. Again, what is AS plus DS? AD. And what is BQ plus CQ? It is BC. So I think we have got it. Let me check. Yes, AB plus CD is equal to AD plus BC. We have proved this. Let's move on to the next question. The next question is, in the given figure, a triangle ABC is drawn to circumscribe a circle. What do you mean by circumscribe? A triangle is circumscribing a circle. That means the triangle is outside the circle. If it is a triangle is inscribing a circle, in means inside. So triangle is inside. Circumscribing means outside. So a triangle is circumscribing a circle of radius 3 cm such that the segments BD and DC are respectively of length 6 and 9 cm, and the area of this triangle is given as 54 cm. We have to find the length of AB and AC. Come on, just try it out. Pause it and try it out, and just comment down below who are able to do it. So let us start. What we'll do, we'll just join. We'll join OB, OC, OA, and these sides of the triangle are touching the circle at just one point. Okay, so they are tangents to the circle. If a triangle is circumscribing a circle, it touches the circle at only one point. So this is the point of contact of tangent. Let us name this A, B, C. Let us name this as D, and let us name this as E. And also we'll join OD, and we are going to join OE. We know, first we can write angle ODC as 90 degree. Again from theorem 1. Similarly, these are also 90 degree. So we can write angle OD. These are the radius also. These are radius of the circle OD, OE. Okay, D we have been given, sorry. So we can name this as E. Just name this as E. And name this as F. Okay. So OE, OD will be equal to OE will be equal to OF. These are the radius of the circle. Also, they'll be perpendicular to the tangents. So we can write ODC, OD, or we'll write this way. OD is perpendicular to BC. Similarly, we'll write OE is perpendicular to AB, and next we can write OF is perpendicular to AC. Now, if these are the, what did I say? These are the radius of the circle. OD is equal to OE is equal to OF will be equal to 3 cm. It will be equal to 3 cm. So we can note this down. These are the radius, and this is from theorem 1. Now, we have been given the area of this triangle as 54 degree. Again, also we can find this full triangle ABC has been divided into 3 triangles. We can say it has been divided into many triangles, but we can see OBC, OAC and OAB. Now using theorem 3, we can say AE is equal to AF. AE is equal to AF. Of course, we have to make use of the theorems. Yes, one more important thing I'd like to tell you, these questions are very important, but the theorems, the 3 theorems which I taught you, I'm saying it again and again, are also very important. Do practice all the theorems. Do practice it hard. So, A is equal to AF, theorem 3. Next we can write B is equal to BD, and from here we can write CD is equal to CF. These are from the theorem 3. Tangents drawn from an exterior point are equal in length. So if A is equal to AF and B is equal to BD, we know BD is 6. So B will also be equal to 6. We know CD is 9. Then this also will be equal to 9. But we don't know AE, neither we know AF. So let us assume it to be as X. Let us take these values to be as X. Let AE is equal to AF is equal to X, and let's just note it down. X centimeter. Suppose it is X centimeter. Now just try to calculate the area of OBC. Just tell me what will be the area of OBC. Area OBC, what we can write? Area triangle OBC will be equal to how much? Half into base into height. Half into 15 into 3. Okay. Next we can write area of triangle OAB. Just tell me, similarly area triangle OAB. Half into 6 plus X into 3. Also we can write area triangle OAC is equal to half into base is 9 plus X and into height is 3, which is a radius. So we have got the area of these 3 triangles. If we add the area of all these 3 triangles, can't we write equal to 54? Because the area of triangle of ABC is 54. Adding these 3 gives us the area of the full triangle ABC. So what we can write? See here, we can write half into 15 into 3, which is 45 by 2. Plus, we can write from this OAB. It will be 18 plus 3x by 2 plus, we can write there 27c. 27 plus 3x by 2, which is area of OSC. And this is equal to how much? Just tell me. Just separate it, okay? This is equal to yes, it is equal to 54. Now on solving this, everybody there can solve it out. I know it. 54 is equal to, just tell me what we will get. 6x plus, just add it out. 45 plus 18 is 63. 63 plus 63, we will get 90. We are getting 90. Cross multiply, 108 is equal to 6x plus 90. So we will get 18 is equal to 6x. So we have got the value of x as 3. X is 3. What will be AB? Of course 6 plus x. So AB is 9 centimeter. And next, what is AC? Which is 9 plus x. It is 12 centimeter. So we have calculated AB and AC. How many of you have got the correct answer? Just tell me down. Let's move on to the next question. Our next question is, in the given figure, 2 tangents RP and RQ are drawn from an external point R to the circle whose center is O. An angle PRQ is given as 120 degree. We have to prove OR is equal to PR plus RQ. So using the theorem of tangents, we can easily prove this. What is given in the question? We'll just write it down. This is given, angle PRQ is 120 degree. And yes, everybody out there is pausing the video and you're doing it yourself. So PRQ is 120 degree, and next we have been given 2 tangents to the circle. So now what we know from from theorem 3, we know that if tangents are drawn from an external point, if 2 tangents are drawn from an external point, they are equally inclined to the line joining the center to that point, which we have seen in one of the questions, so which we have done it. So we know that this angle is equal to this angle from the theorem. That means angle PRO is equal to ORQ, which will be equal to, yes, it will be half of 120 degree, which is 60 degree. So this angle we got as 60 degree. Next step, what we are going to do, we'll join OP. Join OP and angle OPR. What will be angle OPR? Yes, it will be 90 degree from theorem 1. So again, we have got a right angle triangle over here. Now, what we have to prove? We have to prove OP is equal to, OR is equal to PR plus RQ. If we just say in this triangle, in triangle OPR, we need OR and PR. If we are using trigonometry, we are going to solve this using trigonometry. So this is a right angle triangle. We have this angle which is 60 degree and we need OR and PR. So which trigonometric ratio are we going to take? If we are seeing this angle, so this is the perpendicular. We know the opposite of the angle is perpendicular. This is perpendicular, this is base, and this is hypotenuse. We need OR and PR, that is we need base and hypotenuse. In which trigonometry we get base and hypotenuse? Yes, it is cos. So we are going to take as cos 60 degree. What we'll write? Cos 60 degree is equal to B by H, which is PR by OR. What is cos 60? Just put the value of cos 60 is half. Is PR by OR. So we got OR is 2 times PR. right? OR is 2 times PR. We can write as PR plus PR. And what we have to prove? We'll just check what we have to prove. We have to prove OR is equal to PR plus RQ. So in place of PR, just see, isn't it PR equal to RQ? Yes, if the tangents are drawn from an external point, the length of the tangents are equal. So we can write OR is equal to PR plus RQ since PR is equal to RQ. So we have easily proved this. Now come on, let's go on to the next question. So the next question is, in a circle, if a circle touches the side BC of a triangle ABC at P and the extended sides, we have extended the sides of the triangle AB and AC, and this circle is touching the extended sides at Q and R. We have a circle, we have a triangle. The circle is touching one of the sides of the triangle BC at P, and this circle is touching the extended side, means we have produced the side AB. This circle is touching the extended side AB at Q and AC at R. What we have to prove? We'll just see, yes, you have to prove AQ is equal to half AB plus BC plus AC. This AQ is half AB plus BC plus AC. Come on, let us start. So we can write in this question, we can write BQ is equal to BP, right? Tangents drawn from an external point are equal. BQ is equal to BP. Again, theorem 3, the tangents drawn from an external point are equal. Next, similarly, we can write from the same theorem, CP is equal to CR. CP is equal to CR, which is again theorem 3. You don't have to write theorem 3, which I am repeating again and again. Just write the statement of that theorem. Now, what we have to prove? AQ is equal to this. So let us see what is AQ. We can write AQ as AB plus BQ. AB plus BQ. Yes, we can write that from the figure. Next, we can write AR. Write AR as AC plus CR. Again, from the figure. These we can write from the figure. In your exams, just write the reason. Write the reason for each and every statement in order to score good marks. Now what we'll do, equation 1 and equation 2. Next step is we'll add these two equations. Adding equation 1 and equation 2, we are going to get AQ plus AR is equal to AB plus BQ plus AC plus CR. Next is, see, we have another tangents to the circle from an external point P. The two tangents were BQ and BP. From an external point A, the two tangents are AQ and AR. That means AQ is equal to AR. We can write here AQ also is equal to AR. Again, this is also theorem 3. So here we can write, we have AQ here. So we can write AQ in place of AR since the two tangents are equal. Next, we have AB, we have AC. We have AB, we have AC. AB and AC. What we need is BC. Okay, so we need BC. We are saying we have BQ and CR. We have BQ and CR. In place of BQ, if we write BP, and in place of CR, we write PC. So what we'll do the next step is AB plus AC, we'll write it down as it is. BQ is BP, both are equal. In place of CR, we can write PC or CP. Now, we'll get 2AQ is equal to AB plus AC. Just tell me from the figure what is BP plus BC. Yes, it is BC. So we have got 2AQ is AB plus AC plus BC. So we have got it. We can write AQ is equal to half AB plus BC plus AC. So we are done with this question also. We are done with the 7 questions. So we'll move on to the next question, which is the 8th question. I'm telling you again and again, do practice these questions hard. You will score good marks in this topic. So we'll just see what is our next question. Our next question is, prove that a parallelogram circumscribing a circle is a rhombus. I have explained you the meaning of circumscribing. What do you mean by circumscribing? I'll tell you again. The parallelogram is circumscribing a circle. That means a parallelogram is outside the circle. Now, we have to prove this as rhombus. In question 5, in one of the earlier questions, do you remember we had the same question and we had to prove, we had a quadrilateral and we proved AB plus CD is equal to AD plus BC. We had proved this earlier. So, from that question, we can write AD plus BC is equal to AD plus BC is equal to AB plus, which we have proved in one of the questions, plus CD. But you need not write like that, you have to prove it. Okay, you just prove it when you're given this question. I am not writing it because I have proved in one of the earlier questions. So we can write AD plus BC is equal to AB plus CD. Now, we know that if this is a parallelogram, AB is equal to CD. We know AB and CD are equal and we know AD and BC are equal. How? They are opposite sides of a parallelogram. Opposite sides of a parallelogram. As it is a parallelogram. Now, if AB is equal to CD, so in this question, we can write AD plus AD as BC is equal to AD, and we can write AB plus AB. So we have got 2 times AD is equal to 2 times AB. That means 2 and 2 cancel out. So we got AD is equal to AB. What did we get? AD is equal to AB. We have proved this. Now, AD is equal to BC. We know AD is equal to BC. And we know AB is equal to CD. So BC and CD will also be equal. And AB is also equal to BC. BC is equal to CD. So what did we get? AB is equal to BC is equal to CD is equal to AD. So we have proved that all the 4 sides of this parallelogram are equal. So if all the 4 sides of this parallelogram is equal, it is a rhombus. Next, now let us move on to the next question, which is question 9. This question says, in the given figure, there are 2 concentric circles. We have 2 concentric circles. What are concentric circles? Tell me. Yes, circles having the same center and different radius. So there are 2 circles. The center of both the circles is O. Now, PQS and PRT are 2 tangents. Are 2 tangents to the inner circle from point P. Okay, we have an external point P to this circle. We have 2 tangents, PQS and PRT. Now, point P, this point P is lying outside the circle. PR is 5 centimeter. We have to find the length of PS. Okay, let us see. If PR is 5 centimeter, this is 5 centimeter PR. We have to find the length of PS. Okay, so PS and PT, they are tangents to the small circle, and PS and PT are chords to the bigger circle. Right? Agreed? Okay, so we can move like that. If PR is 5 centimeter, just tell me what will be the length of PQ. Come on, my champions, what will be the length of PQ? Yes, it will be 5 centimeter, as they are tangents to the circle PR and PQ and PR. So the length will be equal. Now this will also be 5 centimeter from theorem 3. Next, if we are joining a center to the point of contact, what will be angle OQS? Just tell me what will be angle OQS. Yes, it is 90 degree from theorem 1. No need to mention, write the statement which I am telling again and again. Write the full statements of the theorem. So this is 90 degree. Now just remember, when you studied the properties of chord of a circle, we studied that if a line is drawn from the center of the circle, if a perpendicular line is drawn from the center to the chord, it bisects the chord. Do you remember? Yes. So if OQ is perpendicular to PS, that means it is bisecting this chord. So we can write PQ is equal to QS. Just write down the statement of this theorem. If a perpendicular line is drawn from the center to the chord, it bisects the chord. So that means PQ is equal to QS, and we know PQ is 5 centimeter. We have seen PQ is 5 centimeter from the tangent theorem. If PQ is 5 centimeter, we know PQ is equal to QS. QS will also be equal to 5 centimeter. And we know from the figure what is PS. We have to calculate the length of PS. What is PS from the figure? It is PQ plus QS, which is 5 plus 5, which will be 10 centimeter. It was so easy. Let us move on to the next question. And everybody just comment down who all are able to solve the questions. Just comment it down, and if you're not able to do so, just follow my tip number 3. Just watch half of the video, half of the solution, and try to do rest of the questions. Okay? So we'll start with the question, which is our last question. This question is from a point P, two tangents PA and PB are drawn to a circle with center O. We have a circle with center O. We have an external point P. Two tangents are drawn from this point, which is PA and PB. The length of OP is given as 2R. We have to show that this triangle is equilateral triangle. What is an equilateral triangle? Yes, everybody knows. Equilateral triangle is a triangle whose all the sides are equal and all the angles are equal to 60 degree. So to prove this triangle as equilateral triangle, either we can prove all the sides to be equal, or we can prove all the angles to be equal. It will be an equilateral triangle. Come on, let us start with this question. So first, let us note down what is given in the question. Given is OP is equal to 2R, which is given. Now, the two tangents which are drawn from external point to the circle are PA and PB. So, length of those two tangents will be equal. PA is equal to PB. Next, now what can we do? See, if this is equal to this, we know that this is 2R. First step is we'll join. What we'll do, we'll join this OA. Join OA, which will be perpendicular to PA. So, angle OAP is equal to 90 degree, again from theorem 1. If a straight line is drawn from the center to the point of contact of tangent, it is perpendicular to the tangents. So, angle OAP is equal to 90 degree, and we know that OP is equal to 2R. Okay, if this is 2R and this is the radius of the circle, which is R. OA is R centimeter, OA is R. Now we have to prove this triangle as congruent. Okay, let us, if we take this angle, assume as theta. Let angle APO is theta. Now we can write, if this is angle theta, opposite is the perpendicular and this is the hypotenuse. So we have P and H. Again, we are using the trigonometry. We are using trigonometry and we'll find out this angle. As we have studied in class 9, if we have been given the two sides of a right angle triangle, we can find the angles also. We have studied this. So this angle we have perpendicular and we have hypotenuse P and H, which is sine. Sine is the ratio between the perpendicular and hypotenuse. So we can write sine theta is equal to, sine theta is equal to OA by OP, which is hypotenuse, and OA is, we know OA is R and OP is 2R. So we are getting sine theta is equal to 1 by 2, and what is, we know at sine 30 degree the value is half. So sine theta is sine 30. So we got this as 30 degree. We have this as 30 degree. Now we'll join. Okay, if this is 30 degree, we'll not join Anna. What we'll do, if we have this 30 degree, again from theorem 3, we know that the tangents are equally inclined to the line joining the center to the point, external point. So if this is 30, this also will be equal to 30 degree. So in triangle APB, we have got angle P as 60 degree, right? Now we know in the same triangle APB, AP is equal to PB. We have written this. AP is equal to PB from theorem 3. If these two angles are equal, so angle A will be equal to angle B. Angles opposite to equal sides are equal. Everybody knows it. So this and this angle are equal. So we can write from angle sum property, angle A plus angle P plus angle B is equal to 180 degree. We know P is 60 degree and A and B are equal. So in place of B, we can write angle A. So we are getting 2 times angle A plus 60 is equal to 180 degree. So angle A will be 120, 2 times angle A is 120. Angle A is 60 degrees, so is angle B, as angle A and angle B are equal. So we have proved this as 60, A is 60, B is 60. If all the angles are equal to 60 degree, it is an equilateral triangle. Now we have come to the end of this video. If you want to score good marks on this topic, do watch this video once or even twice and practice all the questions. If you want more videos on other topics, just follow us on Instagram and subscribe to our YouTube channel Midha Guru.